Have you ever wondered what holds our planet together? What shapes the continents, creates mountain ranges, and hides valuable treasures deep within the Earth? The answer lies in a fascinating field called structural geology. Think of it as the science of Earth's architecture, the master blueprint that reveals how our world is built. For a geologist, understanding structural geology is like being able to read the planet's own engineering drawings. So, what is its purpose? Earth's crust is in constant motion. It stretches, it compresses, it shears, and it breaks. Structural geology is the language we use to decode these movements. It helps us answer three fundamental questions. How do rocks deform? What shapes do they take? And how did they get that way? By studying the planet's structures, we can reconstruct ancient tectonic forces and understand the epic story of how entire continents have evolved over millions of years. To understand this story, we rely on the three pillars of structural geology. The first is geometry, mapping the shape of deformation. This is where we identify and measure features like folds, which are bends in rock layers, and faults, which are fractures where rocks have moved. We also look at smaller features like fracture systems and the alignment of minerals, called foliations and lineations. Geometry gives us the 3D form of the structure and helps us piece together the sequence of events, laying the foundation for everything else. The second pillar is kinematics, which is all about motion. Kinematics turns static shapes into a dynamic story. It answers questions like, did this part of the crust stretch or get squeezed? And in what direction did the rocks move? We find clues in the rocks themselves. Certain fabric patterns, called sea fabrics, can reveal the direction of shear. Rotated crystals and asymmetric folds tell us about how the rock was progressively deformed. Kinematics brings the silent, frozen structures to life, showing us the flow and movement that shape them. The third pillar is mechanics, the physics behind why structures form. A rock's behavior depends on several factors: the stress it's under, the temperature and pressure, how quickly it's being deformed, and its own properties. In the cold, brittle upper crust, rocks tend to break, forming faults. But deeper down, where it's hotter, rocks behave more like putty, flowing and folding to create what we call ductile shear zones. Understanding these mechanics is crucial for predicting what structures we might find deep underground. Now, why is this so important? Structural geology is the heart of mineral exploration. It's not just an academic pursuit, it's how we find the resources that power our world. Most ore deposits are controlled by geological structures. These structures act like plumbing systems for the planet, creating pathways for hot, mineral-rich fluids to travel through the crust. They create spaces where these fluids can cool down, react, and deposit their precious cargo of metals like gold, copper, and zinc. For example, many major gold deposits are found in smaller shear zones connected to massive fault systems. Valuable copper and silver deposits are often concentrated where faults intersect or create open spaces. Even kimberlites, the rocks that bring diamonds to the surface, travel up along deep, ancient fractures that cut through the entire tectonic plate. This means that structural mapping is one of the most powerful and cost-effective tools an exploration geologist has. So, what does a structural geologist's workflow look like? It's like being a detective, piecing together clues from many different sources to see the invisible. We start in the field, measuring the orientation of rock layers, faults, and folds. We use tools like stereonautes to visualize this 3D data. We draw cross sections to imagine what the Earth looks like sliced open. We also use remote sensing, analyze drill core, and interpret geophysical data like magnetic and gravity surveys. Finally, we bring it all together in 3D modeling software to build a complete picture of the area. Deformation history. Ultimately, structural geology is the master key that unlocks our understanding of the Earth. It connects the grand scale of plate tectonics with the fine details of rock deformation. It explains how mountains are built and how basins form. It governs the flow of fluids, the location of mineral deposits, and even the behavior of earthquakes. It's both a forensic science, reconstructing the past, and an architectural science, predicting the future. To understand the Earth, to find its resources, or to predict its hazards, you must first understand its structure. It is the framework upon which all of geology is built. Thanks for watching. If you found this interesting, please like, share, and subscribe for more deep dives into the world around us.